Welcome to qnawire.
Hello students, in this question we have a body of mass m equals to 2 kg lying on the rough inclined plane with inclination theta equals to 30 degree. So we have to find the magnitude of force F parallel to the incline needed to the block to move for the part A up the incline. Okay, so drawing the free body diagram. So this is suppose the inclination plane with angle theta and this is the block of mass m. So it will have a weight mg in this direction and mg sin theta will act in this direction and mg cos theta will act in this direction, and the friction force, because it is moving up, so acceleration will be in the upward direction, so the friction force will act in the backward direction. So suppose this is the friction force which will be mu n and normal force will be in this direction. Okay, so in the normal to the inclined plane we can write n equals to mg cos theta, and along the plane we can write here that mu n plus mg sin theta, this is equals to acceleration A multiplied by mass. Okay, and this mass multiplied by acceleration is the net force. So F, this is equals to mu multiplied by n, which is this value, so mg cos theta plus mg sin theta. So now substituting the values, so we will get here that the static friction coefficient mu it also given as 0.2, so F, this is equals to 0.2 multiplied by 2 multiplied by g, which is 10, or we can take here the g 9.8. okay, so 9.8 multiplied by cos 30 degree plus m, which is 2 kg, g is 9.8 and sin 30 degree. So from here, after solving, the force F comes out to be 13 Newton. Okay, so this become the answer for the part A of the problem. Okay, now solving for the part B, in which the block is to be moved in the downward direction. So again drawing the free body diagram. So suppose this is the inclination plane and this is horizontal plane with angle theta, and this is the block of mass m. Okay, and it will have weight mg in this direction and this block is moving in the downward direction. So the components will be mg sin theta and mg cos theta. Okay, and this is the friction force, because it is moving downward, so friction force will be in the opposite direction and it will be normal force n. So in the normal direction to the plane, n will be equals to again mg cos theta, and along the plane we can calculate that mg sin theta minus mu n, this is equals to ma. Okay, this is the applied force. So first of all, checking whether this mg sin theta is greater than this mu n or not. Okay, because we have to calculate the minimum force. Okay, so mg sin theta, this is equals to m, which is given as 2 and g is 9.8 multiplied by sin 30 degree. Okay, so minus mu, which is equals to 0.2 multiplied by n will be this value, so m, which is 2 multiplied by g, which is 9.8 and cos 30 degree. Okay, so this force is equals to 6.41 Newton, which is greater than 0, so it means it already have a downward force in this direction, so we do not need to apply an additional force. So for this situation, the force applied is equals to 0 Newton, because the net force of mg sin theta minus mu n, that is this force, is already in the downward direction. Okay, so we do not need to apply an additional force. So for this situation, the applied force is equals to 0. Okay, thank you.